When you think about AI, there's this one idea that's always been front and center. Bigger is better. But what if that whole concept is just wrong? Today, we're going to dig into a really fascinating paper from NVIDIA Research that basically flips the script, arguing that the future of AI isn't big at all, it's small.
And wow, they do not pull any punches. The paper leads with this incredibly bold statement right here. It says that small language models, or SLMs, are the future. But the future of what exactly? Well, to get that, we need to understand this whole new area that's just exploding right now. And that field is called Agentic AI. This is a huge deal because it's not your everyday chatbot. We're talking about a leap from AI that just chats with you to AI that actually does things. It's a pretty fundamental shift in what we expect our tech to do for us.
So what does agentic really mean? Well, it's all about having a job to do. So think about an AI that doesn't just tell you about flights, it actually goes and books them for you. Or one that doesn't just see your calendar, it actively manages your schedule. It's AI with a purpose, using language models as the brain to get things done.
And get this, because this kind of AI that takes action is so incredibly useful, the market for it is expected to hit nearly $200 billion by 2034. We're not talking about some niche little idea here. This is poised to be a massive part of our economy.
Which brings us to the underdog in our story, the small language model, or SLM. And the paper's definition for it is just so simple and powerful. If it can run right there on your phone or your laptop without a ton of lag, it's an SLM. This is AI that's tiny, it's fast, and this is key, it's local. Okay, so this slide is super important for understanding how this all works. It shows the two main ways you can build one of these AI agents. On the left, you've got one big, powerful language model that's basically the whole brain. But on the right, you have this more modular setup where the language model is just one tool in a bigger toolbox. And it's this setup on the right where these small models can really shine. You can build a whole team of little specialists that are way more efficient. So the big question is, why is this NVIDIA paper betting the farm on these small models for this huge new market? Well, it really all comes down to three main arguments. All right, so they break it down into three core points. First, they say SLMs are already powerful enough to do the job. Second, they're just a better fit for how agents actually operate. And third, and this is a big one, they are way, way more economical. Let's start with that last one, because the numbers here are just staggering. Just look at this chart. It tells you everything you need to know about the money side of things. Running a single task on a small model can be anywhere from 10 to 30 times cheaper than using one of the giants. And that's because they just sit power compared to the big guys. Now imagine you're a company deploying millions of these agents. That cost difference becomes absolutely astronomical. But here's the kicker, and this is what really blew my mind. It's not just about being cheaper. The paper points to this model from Salesforce that, even though it's just a tiny fraction of the size, is already beating monsters like GPT-4o on specific jobs, like tool calling. That's basically an AI's ability to use other software. So yeah, in some cases, smaller isn't just cheaper, it's actually better.
Okay, so this is all sounding pretty great for the small models, but I know what you're probably thinking. We have to address the elephant in the room, or I guess the giant language model in the server farm.
I mean, this is the question, right? For years, the story has been that size is what creates the magic in AI. So the paper really have to tackle this argument head on.
So the argument for the big guys, the LLMs, really boils down to two powerful concepts. First, you have what are called scaling laws, which basically just say that as you make a model bigger, it reliably gets smarter. And second, there's this newer idea of a semantic hub, sort of like a central knowledge processor that lets these massive models connect ideas and generalize in ways smaller models just can't. So you've got scaling laws, you've got this incredible semantic hub. How on earth can the little guys possibly compete with all of that raw intellectual horsepower? Well, the paper's answer is actually pretty brilliant in its simplicity. Let's see how they do it.
The whole rebuttal is this. Agentic AI changes the rules of the game. Remember, these agents take big problems and break them down into tiny, simple little steps. And for those simple steps, you don't need a model that's read the entire internet. It's like using a supercomputer to do basic math. The LLM's vast knowledge becomes expensive overkill. You just need a specialist that does one small thing and does it perfectly.
Okay, so that's a pretty compelling argument, which leads to the next logical question, right? If these SLMs are cheaper and sometimes even better for the job, why does it feel like the whole industry is still obsessed with these giant centralized models?
Well, the paper points out that the hurdles aren't really about the tech itself. It's more about, well, inertia. Companies have poured billions into LLM infrastructure. The benchmarks we all use to measure AI performance are kind of biased towards the big generalist models. And, let's be honest, the giant AIs get all the crazy headlines.
But here's the great thing. The paper doesn't just point out the problem and leave it at that. It actually provides a solution. It lays out a clear, step-by-step blueprint for how any organization can start making this shift.
They call it the LLM to SLM conversion algorithm, which sounds a bit complicated, but the idea is actually super straightforward. You basically watch what your existing AI is doing, find the repetitive, specialized tasks it's performing, and then train a small, dedicated SLM to handle each one of those tasks perfectly. It's like swapping out one overworked generalist for a whole team of hyper-efficient specialists.
And that really brings us to the final huge question this paper leaves us with. What kind of AI future are we actually building? Is it going to be one single, all-knowing brain sitting in the cloud somewhere? Or is it going to be a globe-spanning team of nimble, efficient, and accessible specialists all working together? It feels like that debate is really just getting started.